Similarly, they can also work as a high pass filter. Notice here, you know, the configuration has changed a little. You got this voltage divider configuration, and in series with R1, you have a capacitor C1. So again, remember, this is the relationship Xc equals to 1 over 2 pi Fc. When the frequency goes up, R has no effect upon the amount of feedback going into the inverting terminal. So more will be shorted. Okay, so more will be shorted. The more signal will go to the ground through the negative feedback. This right here, through this negative feedback over here. Okay, because this offers less resistance. And remember, no current can flow here, right? No current can flow here because this is a high input resistance. Okay, so the reactance of the capacitor increases and there's more negative feedback, which results in the lower gain, just like we were doing a correlation over here between reactance, frequency, and the gain. And as the name implies, this high pass filter is going to allow, you know, pass higher frequencies, okay, and rejects lower frequencies. Okay, again, what these frequencies are, these cutoff frequencies are depending upon the value of the resistance and the capacitor over here. Okay, the shape of the curve is of importance here. If I show you graphically, you will have again a frequency here for a high pass filter, and again this is some magnitude, some normalized output power, say magnitude. It's going to block the lower frequencies. Once it hits the cutoff frequency, it's going to allow everything that is offered that has a higher frequency. Okay, so all of this will go past the higher frequencies and all of this will be blocked.